Okay, hello. So here is a problem that telling us about this three vector is this three vector. Is this three vector are linearly independent and or this four vector linearly dependent or not. So we have to prove that these three vector are linearly independent and these four vector are linearly dependent. Okay, so this is not a very complex problem. It is a simple problem of linear algebra. So what should we do? At first we will prove that. So basically I don't get it in the solution in the solution manual, so I make the solution by my own and I am showing you this stuff. If you get any problem you can comment. Okay, so let's start. Okay, so at first we will take the general linear combination of these three vector. Okay, so then it's look like something C1 to 1 0 0 plus C2 1 0 and C3 1 1 1 1. So then we can combine these three vectors like C1 C2 C3 C2 C3 C3. So here we will apply some intuition of our to solve this and to solve this problem. So to prove linear independent or dependent, what we have to do? We generally do prove the left side equals to 0. So this is our left side and we want to make this thing equals to 0. So consider that the easy way will be if we consider C1 equals to 0 and C2 and C3 like C3 equals to minus C2, then something will happen like C1 0 plus C2 minus C2 minus C2. So here what we have done, we just simply take some value to make this left side equals to 0. It's all about our thinking. Okay, so then what we will get in the next line, it will like 0 0 minus C2. So this is a general solution that is close to 0 for this particular V1, V2, V3. But we see that this column matrix is not equals to 0 because there is a minus C2, and it can be 0 if C2 equals to 0. So we see that this thing is 1 0 0 1 1 0 1 1 1 and C1 C2 C3, this whole thing will be 0 if and only if C1 C2 C3 equals to 0. Without C1 C2 C3 equals to 0, this can't be this linear combination can't be 0. So that's why, so by this thing we see that this V1 V2 V3 are linearly independent. So by this way we can prove that these three vectors are linearly independent. So this is the proof of the first part, and the proof of second part will be like, it's a very simple thing. We know that it is what is the matrix, or sorry, what is the column matrix? Vectors are 1 0 0, 1 1 0 and 1 1 1. So what do we see? We see that these vectors are three-dimensional. That means these all vector are in R3 space. So that means we know that from the linear algebras and some kind of what should I say, some kind of assumption or calculation, we know that for R3 space, or for R3 space, if we take greater than 3 vectors, like if we take 4 vector to span the R3 space, then this 4 vector will not be linearly independent. It will be absolutely linearly dependent, because and we can use our simple intuition. See that these 3 vectors are linearly independent, and these 3 vectors are spanning a space. So that means these whole 3 vectors are spanning R3. That means if we take another vector, like what was the vector, 2 3 4 from the R3 space, then it will also the linear combination of these 3 vectors. This vector is also linear combination of these 3 vectors, because it came from R3 space. So since these 3 vector are combination, this vector are combination of these 3 vector, that means these 4 vector are not giving us some new things. That's why these 4 vector are linearly dependent. Because what was the rule for linear dependency and independency? It was the C1 x C2 x dot plus Cn x n. Suppose, so if and only if the combination of this thing get 0 by consider this constants part as 0, then it will linearly independent, otherwise it will linearly dependent. But in this case, we can see that the linear combination of this thing and minus this thing will produce 0. That is not as same as the condition of linearly independent. So that's why we can say these 4 vectors are linearly dependent. And the easiest way is these vectors are in R3 space, and we are taking combination of 4 vector or of R3. So we can easily say that these 4 vectors are linearly dependent. I think you have understood. If you don't, then please replay the video. Thank you.